Hello everyone, this is Samada Pratima, Assistant Professor, EC Department, RMK CET. Today in this video lecture we are going to see intersymbol interference, the first topic in Unit 3, baseband transmission and reception. That subject is digital communication. Before going to see the first topic intersymbol interference, let us see the contents in the Unit 3, Nyquist criterion for distortionless transmission, pulse shaping, correlative coding, I pattern, receiving filters, in that matched filter, correlation filter, correlation receiver, and adaptive equalization. These are the topics of Unit 3, baseband transmission and reception. Now the first topic, intersymbol interference. So before going to understand what is intersymbol interference, let us see the baseband binary data transmission and its system. So here we are having transmitter and the receiver, and at a transmitter side we will have the data input binary sequence. It is given to, that is ones and zeros, it is given to a pulse generator. Pulse generator is supplied with clock pulses. In order to sync the input and output, we will use these clock pulses. So pulse generator, two inputs, one is our binary information ones and zeros and clock pulses, and these two get multiplied to produce the sequence signal x of t, pulse period, that is pulse train x of t. Here this may be represented in terms of unipolar, bipolar, polar representations, which we have seen in our second unit, that is waveform representation and coding. We have seen these type of representations. You can represent these binary sequence, that is ones is represented by positive voltage and zeros are represented by negative voltage in polar form. If in unipolar, ones are represented by positive voltage, zeros are represented by zero voltage. So like that we will represent the binary data, and it is synchronized with the clock pulses. Each and every clock pulse, one bit of information will be transmitted, and x of t will be produced by pulse generator. Now this waveform is transmitted through transmitting filter, which is having transfer function ht of f, and it is given to a channel hc of f. It will be transmitted through the channel having a transfer function hc of f. Here baseband transmission system, the transmission channel will be coaxial cable or optical fiber waveguides. And the receiving filter, receiver side, we are having the filter, receiving filter of transfer function hr of f, and each and every sample time ITB, t is equal to ITB, the switch will be closed and this y of t will be sampled. So decision device will be used to take the decision based on the threshold value. It will compare the incoming signal y of ti with the threshold. If it is greater than that, then the pulse, it is assumed as pulse 1 is transmitted, bit 1 is transmitted, and if y of ti is less than threshold, it is decision device will take 0 is transmitted. Like that at receiver side, the decision device will produce output binary data. So this is pulse transmission through baseband binary data transmission system. So now let us see if that channel, here we are having in a baseband transmission, we are having a channel in between transmitter and receiver. If that channel is band limited, then what will happen to the input pulse? If input pulse, let us consider this is the input pulse and this is x-axis time period, y-axis amplitude. This pulse is transmitted through band unlimited channel. So here there is no limit of the, that is there is no limit in frequency. It is constant transfer function, it is having constant amplitude for all frequencies. Then there is no problem. Whatever the signal we are transmitting, we will receive the same shape, we will receive at the output side. For band unlimited for unlimited bandwidth channel. And if the transmission channel having it is a band limited channel, then what will happen means this input pulse will lose its shape. So let us consider this is band limited channel having bandwidth minus b2 plus b. So if this bandwidth is sufficient to transmit this input pulse, then no problem, we will consider it as a band unlimited channel, so as such we will receive. But this bandwidth is not suitable to transmit, that is less than for transmitting a input pulse means then it will lose its shape because of dispersion exists in the channel. The pulse get dispersed in band limited channels, so the output pulse will take this shape, it get dispersed. So because of this dispersion, this secondary lobe, this point, this is called secondary lobe. This secondary lobe now it will interfere with the next transmitted pulse, next subsequent transmitted pulse, and creates some distortion, that is unwanted distortion. It is called intersymbol interference. Let us see what it is. So now so in all digital systems the pulse are transmitted from the transmitter to receiver. So here we are considering it as a pulse transmission system. So if the channels carrying these pulses having enough bandwidth required to ensure the preservation of the shape of the pulse. If there is no enough bandwidth, then those channels are said to be band limited channels. If it is having enough bandwidth, even though unlimited bandwidth, enough bandwidth is there means then we can call it as unlimited bandwidth channels. Band limited channel tends to spread the narrow pulses, though, so the pulse will get spread. So dispersion will exist and they will produce secondary lobes. So these secondary lobes are called as ringing tails. These secondary lobes are called as ringing tails. So these are called this is secondary, this one is called ringing tail. For this second pulse, this is called ringing tail. This secondary lobe is called for first one this is called secondary lobe, this is called ringing tail, and for second one this is called ringing tail. So this figure shows energy distribution in the output of a band limited channel. So here 90% of energy, this is 90% of the energy. So most of the energy is contained in the main lobe only. This is called main lobe for the first pulse, and this is called ringing one, and this is called secondary lobe, which got interfere with the secondary pulse. So this is for single pulse transmission. If a single bit either 1 or 0 is transmitted, then what is happened to the output of the band limited channel. And the process of residual signals at the receiver output due to other symbols interfering the required symbol is known as intersymbol interference. So because of unlimited bandwidth of the channel, limited bandwidth of the channel, the symbol will disperse when it transmitted through limited bandwidth channel. It get dispersed and it get interfere with the subsequent symbol, and that distortion is called as interference, is called as intersymbol interference. That is spreading of pulse beyond its allotted time period. If it is confined to this time period, then no problem, but it is came out of time period pulse width, then it will tend to interfere with the next pulse. So that interference is called as intersymbol interference, ISI. So ISI, why ISI arises in band limited channels means because of dispersive nature of communication channel. In band limited PCM, pulse code modulation channel, the received pulse waveform is distorted and may extend to the next time slot. This may result in error in determination of received bits. Sometimes it may give confusion between whether bit 1 is transmitted, bit 0 is transmitted because of this distortion. So ISI is undecidable phenomenon. Actually ISI is undecidable phenomenon and results into degradation in the performance of the digital communication system. So this is showing intersymbol interference when a group of bits is transmitted. We have seen previous slides, a bit is transmitted, then what will happen? Now a sequence of bits are transmitted, that is here 4 bits we have assumed. If 4 bits together transmitted as a frame, then what will happen at the receiver? So let us consider here the pulse transmission is having limited bandwidth. So because of limited bandwidth, the pulse get dispersed and it will appear into the second the time. It is not confined into its time period, it is beyond its, it came in beyond its time duration, pulse width duration, and it will interfere with second bit duration, second symbol. So here if you see a bit 1 is transmitted and it get dispersed like this. So at the receiver side, actually for 1 bit no problem, but if a group of bits, sequence of bits 1 0 1 1 is transmitted, so at the output side this get dispersed, this one bit get both the bits get dispersed, and we don't know the bit which bit is transmitted at this point. We can consider this bit as 1 because of this 1 and this 1 dispersion. Here we are getting some threshold, it crosses, if it crosses beyond the threshold, then the decision making device may get confused and it will detect as bit 1 is transmitted. So this is undecided one, that is intersymbol interference. So in this unit we are going to take care of not to occur this intersymbol interference, and in subsequent topics in this unit we are also use this intersymbol interference concept for saving the bandwidth, that is number of, to increase the number of bits also we will use this concept in correlative coding, but there we will introduce intersymbol interference in controlled manner. So in the absence of ISI, that is if the channel is unlimited channel of bandwidth, then the transmitted symbol can be decoded correctly at the receiver, but due to the occurrence of ISI, an error will be introduced in the decision making device at the receiver output. So we need to take care of this ISI. If ISI is left over, then the decision making device may take the decision, faulty decision. So I hope you have understand something about ISI. Thank you.